Hello, my name is Aaron. I'm a second year mechanical engineering student. Throughout history, humans have demonstrated tremendous amount of interest in the Arctic exploration and development activities. In this presentation, I will start off by briefing on multiple historical attempts humans have made to explore the Arctic and how that has evolved over time, and also how does mechanical engineering helped to tackle the most pervasive challenge, ice, in those exploration activities, and in particular the level impact it had on the oil and gas industry. In the end, I will wrap this thing up by telling you a little bit on how does this development help the Arctic community to connect better with the rest of the world. Arctic exploration is the physical exploration of the Arctic region of the Earth. It refers to the act of humankind exploring the region north of the Arctic Circle. Historical records suggest that humankind have explored the northern extreme since 325 BC, when the ancient Greek sailor Pytheas reached the frozen sea while searching for the source of metal tin. Exploration above the Arctic Circle in the Renaissance was primarily driven by rediscovery, classical learning, and the national quest for commercial expansion. These explorations was accompanied by limits in maritime technology, lack of stable food supplies, and insufficient insulation against extreme cold. That's why, in order to successfully explore and harness the abundance of resources in the Arctic, the primary challenge, ice, must be dealt with first. Ice is a pervasive reality of the Arctic environments. Therefore, it is absolutely critical for us to understand the characteristics and behavior at the molecular level. Ice mechanics is a foundational topic for all exploration-like programs, since accurate modeling of the mechanics of ice and the structural interactions are needed to develop a proper design methods and effective station keeping and ice management models. Despite many challenges posed by pervasive presence of ice, industries have developed feasible solutions for production from fields in marginal sea ice and iceberg zones, such as the Granite Banks, as well as capabilities to safely conduct exploratory drilling in areas such as the Beaufort Sea. The Hibernia development, for example, relied upon a heavily toothed and steel reinforced concrete gravity-based structure to resist and dissipate the force of iceberg impact. On top of that, the Arctic Sea is covered in ice 9 months of the year. Despite widespread public perception that Arctic ice is disappearing, managing, breaking, evading ice remains a major concern for exploration production operations at high latitudes. With many challenges tackled with improved mechanical engineering technology, the oil and gas industries have experienced major breakthroughs in their attempts to explore the Arctic. Back in the 1970s and 1980s, extensive drilling was done in the Canadian Arctic. However, developing oil and gas in the Arctic calls for innovation not needed farther south. That's why artificial islands of silt and ice were built to allow drilling in shallow waters, and in medium depth water, steel and concrete platforms called caissons were needed. A major breakthrough was the converted tanker SSDC, also known as the single steel drilling caisson, which sat on a steel platform that could be moved, allowing year-round drilling and oil storage. Drilling in deep water required ice-strengthened drill ships, including a revolutionary 8-sided vessel. Other innovations were airstrips built of thickened ice, new icebreaker designs, ice-breaking supply boats, and floating dry docks for services of other ships on site. In the midst of the expansion of the resource industry, the Arctic community has also benefited a lot. See, new transportation links within the region and beyond were built, and also the increased use of air and marine transport has helped to alleviate the isolation of the Arctic community. At the same time, the internet, wireless services, and other information and communication technologies are also connecting the Arctic communities with one another and also with other regions, creating new opportunities for personal interactions, telehealth services, education, and business development. In this presentation, I've talked about how has humans' attempt to explore the Arctic evolved over time, and how does improved mechanical engineering technology help to tackle the most pervasive challenge, ice, in those exploration activities, and in particular the level of impact it had on the oil and gas industry. I also talked about how does improved technology help to benefit the Arctic community and made it increasingly connected virtually and physically with the rest of the world. Thank you for watching this video, and please feel free to leave any comment below.